Altshuller started inventing when he was 11 years old. He got his first patent document. He became interested very much in the world of inventions. How did people solve problems? How were they defining a problem? How were they solving it? All that became part of his interest, and he became obsessed about it. And he joined a patent office, and that's where he found out what he wanted to find. In the patent office, he was excited that he was surrounded by all the inventions, documents that he read about. All the great inventors of humanity had documented how they had actually solved problems. This is very exciting for him. He read through all those dossiers as if they were fiction novels, right? So he went through 20,000 such documents. And then slowly it dawned on him. Slowly he started categorizing each of those inventions with the respect to the type of problems that they had solved. All that they started categorizing them one by one by one. And what resulted was almost like a formula. This type of problem solved this type of way. There are about 39 parameters that played a role in defining a problem, and 40 ways in which things could be solved. Only 40 ways in which any problem could be solved. That's what he said. Sum total of 40 ideas in the entire universe is how humans have been solving a problem. That's what it was. But then something drastic happened. He was thrown into the prison. Why was he thrown into a prison? Because he wanted to bring about a huge change in his country, USSR, back then. And the head of state apparently didn't like what he had said in his letter about the current state of how the country was run. So he was thrown into prison. And was he quiet there now that he has come up with this formula, this theory? Was he quiet? What does he do next? In the prison, whom did he meet? He met biologists, physicists, chemists, mathematicians. All of them were there for political reasons. So he used the time in the prison very usefully by taking his theory of problem solving to all these people and seeing how does it apply in their domain. So he made some changes according to what they thought should be done. And then came out the beautiful theory of inventive problem solving. And in Russian, he translated and abbreviated it as TRIZ, TRIZ. So theory of inventive problem solving is meant as a powerful methodology to help you define and solve problems, and made it a very formulaic way to do it to enhance the inventor's already existing thought patterns. That was what was TRIZ all about, and that's what we will cover in this course. There are other principles that you can learn from and apply it in whichever problem you're working on. Look around yourself and think about what principles actually were applied in solving a certain problem. So I'm going to show you some examples, some objects in this activity center that you will find to be an approximate equivalent of the application of these principles. Okay. For example, the first one we'll start with is a principle I like, is called copying. Okay. Copying is usually referred to in a negative connotation, particularly in exams. You're not supposed to copy, which is very good. But in inventions, you can actually, copying is a great idea to do this. So look at this. These are actually two knives. Two knives, when they are put together like this, can actually do a completely different function. And that was the origin of the scissors, right? So this is a craft object which looked very nice. So I brought it here with me to show you that you can copy and create art. Art is about having patterns and repetitions, and that will give you this. So copying is heavily used in art when they copy the same designs over and over again, and you can get, even design thinking is copying again and again. EAST, empathize, analyze, solve and test, is repeated over and over again to give such patterns. Okay, so that was copying. Now I'm going to show you another one. This is called the moment you see this, you know what principle is in motion here. Okay, so this is often called a Swiss Army knife. Okay, this is what the term that we use for this. But the principle involved here is universality. What is universality? The very same object can be used for various purposes. So, if you have a startup, a small company, the sales person will also be responsible for marketing, who is also responsible for, I don't know, administration. Okay, so it's the same person who does so many functions. So this principle is also pretty useful, because you can have one object, one thing, but it can do many other functions. You can overload this with many other functions. So in programming also, we use one function to deliver several outputs. So that could be your example of universality. Okay, now another common principle is, I'll show it to you very soon. This is a regular mirror in my hand, but it's actually split. I don't know if you can see it, or segmented. Okay, so segmenting works with a large project. What do? You normally segment it. When you see a birthday cake, what do? If you want to share with your friends, you split it, you segment it. So the same thing here also, we segment it and it becomes a kaleidoscope. One of my colleagues showed this, how this works. Pretty interesting stuff. So you have mirrors and it forms a kaleidoscope, right? So this is segmentation at work. Now, another example of segmentation could be, in one sense, a spring, a pattern repeated over and over. This could also be copying. So you will see that multiple manifestations of principles can also be there. This is a slinky, right? This is a spring. So you can see copying plus segmentation all rolled into one. So two principles into one. So I'm going to show you another example of where two principles are rolled into one. This one is an object within an object. In one sense, it's a nested doll. This is a box cutter, a simple box cutter. But what you can also see is the fact that it is a cheap disposable object, as it's called. So use it once and throw it. So it's a cheap disposable object. So you can actually clip off one part of it, and you can get another sharp end. So that's a cheap disposable object. Your tissues that you use, those are all cheap disposable objects. So anything that you use and throw, any product that you can think of, those are all cheap disposable. These are all simple principles. Oh, this one is a most common example of cheap disposable. Paraffin wax is so cheap that you can use and throw, right? So in one sense, it is a cheap disposable object. You can light it up. It serves the function of lighting up or heat in some cases, but it's a cheap disposable object as well. So here is my attempt to show you all sorts of things that lie around in many people's homes, and there are principles, inventive principles applied there for so that your life becomes better. So now the appeal to you is to look around. So there are two parts to this. One part is look around your homes or classroom or offices and see which principles that I mentioned actually apply. Okay, it could be, we have talked about segmentation, we talked about nested dolls, we talked about cheap disposable objects, we talked about copying, we talked about universality. So these are some principles that we talk about. Altshuller came up with 40 ideas, types, right? So categories, inventive principles that could be used. So you could look around your home and see, or school or office, and see which ones are the ones that these principles apply. That is one part of it. The second part of it is that you can now look at unsolved problems and apply these principles to see if you can generate an idea. That's the other cool part of it. Now you can be creating and solving problems instead of categorizing them. So both are okay. You can try both of these and have fun with it. Okay. So keep doing this, looking at solutions, trying to find what principle it could be, or principles in some cases, or do the other way, which is find out a problem and see if you can apply those principles to generate ideas. Okay, this is how the principle of problem solving really works. Problem, solution, solution, problem. That's how it works. Okay. So have fun. Here's me playing with marbles. Okay. And have fun again.